Hello and welcome back to the channel, guys. Before we actually dive into the problem of the day for today, let's talk about a little motivation, a little inspiration for ourselves, because obviously I think we need it the most. These people, visionaries, I think they are the ones who aim high, who set ambitious goals, and those goals can be anything. They can be related to your health, they can be related to your professional, they can be like that in 1 year of time or in 6 months you're going to clear Google's interview or Meta's interview or anything. It's highly personal. But then one thing which you need to realize, and it's very important, something which you need to realize is that the clarity of your goal, what you want to achieve, should be crystal clear to you. I'll give you a very simple example. I think there are two types of people in competitive programming. Number one are those who want to get good in competitive programming. They want to win contests. They want to, that kind of people who are more interested in the competitiveness of competitive programming. And then there are people like me who entered this field, who entered the problem solving domain in order to perform good in technical interviews. Now, although both of these things, they require you to do very similar kind of hustle, very similar kind of work, right? At the end of the day, you're solving problems, right? But then it's, if you are aiming for this, the type of questions which you are going to do are going to be very different from the ones which you need to do in order to clear technical interviews. Now, the point is, if your goal is clear, your strategy is going to be fine grained as well for that particular thing which you want to achieve. So keep that in mind. Recently I was going through an article. That person interviewed at Meta, at Google, and then he was basically talking about, discussing how the whole interview process went. Like, this is the actual article which I'm also going to this is a very comprehensive, by the way, very detailed article. I'm going to mention it in the description of this video. Do go through it. I've highlighted, by the way. If you want, you can pause this video and have a look at it. So if you're, for example, aiming for Google or Meta or Netflix, if you're aiming for the tech giants, this is very important for you, right? So without any further ado, let's now talk about the problem of today. It's Leetcode 2161, partition array according to given pivot. A very simple question actually, and again, I actually learned something very valuable from this problem today. I'm going to share that particular tip with you as well. You're given a zero indexed integer array nums, something like this, and you're given a pivot. What you have to do is rearrange nums such that every element which is less than 10, which is less than the pivot, appears before every element greater than pivot. So for example, 9, 5 and 3, these are the numbers which are less than the pivot, so they should appear before every element which is greater than the pivot, such as 12. And then you can very clearly observe that 9, 5 and 3, they appear before 12 in the resulting array. Every element equal to pivot appears in between the elements less than and greater than pivot, obviously. So this is the pivot, the number is larger, the number is smaller, something like that. So you have to relatively order all of them. The relative order of the elements less than the pivot and the greater should be maintained. So again, thing is, 12 comes before 14, so that order should be maintained. 9, then 5, then 3, so that order should be maintained, right? This is another test case, for example. So thing is, this was the pivot, right? And I was provided with two pivots over here, right? In this case, I have the pivot at the end. So there's this -3, which is smaller. Maybe let me change color, which is smaller. Then this is bigger. This is also bigger. So apparently the pivot should go somewhere over here, isn't it? And you can very clearly observe that as well. The mistake which I did while attempting this question was, I actually started thinking from the optimal approach. I directly started to think about how I'm going to sort these numbers and how can I achieve the goal in O of 1 space complexity, so on and so forth. I did not consider the worst case implementation. And that, you see, this question, if you are a good enough programmer, it's going to take you 5 minutes, not more than that, 6 minutes maximum. It took me 30 minutes. So it took me 25 minutes of thinking which went nowhere, which did not lead to any value, no value. And then the idea struck. After 25 minutes of wastage, the idea struck, and I solved this question in like 3 minutes after that. It's as simple as that, right? And I'm 100% sure after reading the question, you at this point you probably must have figured it out on your own how you're going to solve it, right? So let's start thinking from the brute force approach, the bare bone brute force approach, how we are going to do this question, right? So in this case, the pivot was 10. The pivot was 10. I started thinking like this. What I'm going to do is I'm going to label each number such like this is smaller, this is bigger, this is smaller, this is equal, this is bigger, this is smaller, and then this is equal. I thought what we'll do is first of all, I will sort of group all the equal to the pivot numbers, all the pivots. I'll bring all the pivots together. So something like this, 10 and 10. I'll do that on, obviously if I bring this 10 backwards, I will have to shift the 14 and 3. I will have to shift this whole thing one place to the right, isn't it? So 14 and 3 go over here and this remains as it is, right? Then I started thinking about, okay, now the good thing is that the pivot is actually at its position. Right now I don't know if it's the correct position or not, but it's somewhere. All the equal elements, all the equal to pivots elements are together somewhere in the middle, right? So now what I'll do is I'll bring all the smaller numbers to the left and I will take all the larger numbers to the right, while making sure that the relative order remains the same, because we cannot change that, right? So I was thinking of such an approach. Thing is, you see, this number is smaller than 10, this number is smaller than 10, and then this number is smaller than 10. So it goes without saying that this smaller number should be after this smaller number, isn't it? Should be 9, 5, and 3. And when I do that, obviously, this 12 has to go somewhere, right? So actually, when I shift the 3 backwards, I'm going to do it in such a way that 3 is placed after 5. So I have 12 over here, I have 5 over here. When I place the 3 over here, I'll have to shift the 10, 10 and 14 one place towards the right, isn't it? One place towards the right. Now, the good thing is every smaller number, 9, 5 and 3 is on the left hand side of the of this equality group, of the pivot group. Now, after the first step was you bring all the pivots together. Second step was you bring one by one, you bring all the smaller numbers towards the left. What would be the next step? The third step would be that you think about the bigger elements, all the ones which are on the wrong side of it, on the wrong side of things, right? So for example, this particular element, this needs to go towards the right. So what I'll do is now I'll shift it towards the right hand side while maintaining the relative order. So it's going to become 9, 5, 3, then the group of tens, followed by 12 and 14, because obviously 12 was previous to 14, isn't it? And this is actually the correct answer if we observe the test case. 953, smaller group, equality group, and then the larger group, isn't it? So I was thinking of such an approach. Similarly, this is smaller, this is bigger, this is bigger. So what I'll do is I'll take the pivot and I'll place it somewhere where, on the left hand side I have all the smaller numbers, on the right hand side I have all the bigger numbers. I was thinking of such an approach, but could it be made any simpler? Could it be made any simpler? And I think so it can. You see, if I give you random numbers, 20, 50, 60, and 21. So these are, some of them are even, some of them are odd. And I tell you to sort them in a way that all the even numbers appear first. Appear first. What are you going to do? You're going to traverse the array, right? You're going to make actually two arrays, even and odd, right? you're going to do is you're going to traverse all these numbers one by one. If the current number is odd, you're going to push it back in the odd array. If the number is even, you're going to push it in the even array. At the end of things, inside the even array, what are you going to have? You're going to have 50, 10, 20, and 60, isn't it? Inside the odd array, you're going to have 21 and 11. So in the end, what you have to do is just take these two numbers and put them over here, append them at the end of the even array, 21 and 11. The good thing about this is that it maintains the relative order as well. So taking some extra space, this question becomes very easy for us, and that's why I was actually saying that it's just it 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 deserves 5 minutes of yours, not more than that. Just 5 minutes, right? So it's as simple as that. The key learning point for me from this question wasn't actually how hard this question was. It was actually that always start thinking from the most simplest approach. How can you write the simplest code? No optimization, no nothing. How can you, in the very simple manner, solve this particular problem? So having said that, let's now directly talk about how the code is going to look like. So what I have done is I've created two vectors, two lifts, basically two arrays. One I have given the name of before and one I have given the name of after. So before is going to contain those elements, those numbers which are smaller than pivot, and after is going to contain those elements, those numbers which are greater than the pivot. Now I actually didn't need to take a vector of integer for all the pivot elements, right? Because I know what the pivot element is. So I'm just taking a variable over here and I'm just going to count how many pivot numbers are there inside of my array. And I'm going to just sort of push back those number of pivots inside of my answer array, right? So I take a for loop. What I do is if nums of I, if the current number, if it's less than pivot, I push it back in before. If it's larger than pivot, I push it back in the after array. And if it's equal, I'm going to track its count. So how many elements do I have inside of my original array? How many elements do I have which are equal to the pivot, right? Then what do I do? Now, if you think about it, the before array already has the elements which are smaller. So you don't need to actually create another array for answer. What you can do is after 9, 12 and 5, you can push back 10 two times because you had twice number of pivot elements, right? So that's what we are going to do. That's exactly what I'm going to do, right? What I'm going to do is this. While same minus minus, so I had two number of pivots, right? I'm going to push back 10, which is the pivot number, two times. So 9, 9, 5, 3 was already there in the before array. I push back to 10 times, and then what I have to do is whatever is inside the after array, just push it back inside of the before. So that before at the end of the day is going to become your answer array. Does that make sense? I hope it does. It's as simple as this. You see. So the key learning point from this particular question for us today was always and always think about the brute force first, then optimize it, right? So having accepted this question, having very easily solved this question, let's very briefly, very quickly talk about what the time complexity of this code is going to be. You can very clearly see that all the elements inside of my original input array, I just visit them once, right? I just visit them once over here, and then I just sort of like in the worst case, what's going to happen is I'm going to have all the numbers which are either equal to the pivot or which are either equal, which are greater than the pivot. But at the end of the day, all of this logic, it takes me O of n number of operations. It's very clearly linear, right? And since I'm storing all of these numbers in apart from the pivot, I'm either storing them in the before array or the after array, so it takes me O of n extra space as well. The challenge for you would be if you could accomplish this task, since the uh, constraint, since the length of the nums array is 10 to the power 5, obviously the best, you can't do O of n square over here, right? That's going to give you a time limit exceeded error. The challenge over here is if you can solve this question in O of 1 time complexity. in constant time complexity. If you can, do let me know in the comments. I hope the video was helpful for you, and I'll see you next time. Till then, take care. Allah Hafiz.